Hi, this is Luziz Khan, and this is lecture 15 of the basics of microwave propagation. So, in the last lecture, we finished the diffraction portion, and now we have entered the reflection portion. So, initially in this video, we will talk about the radio wave reflection, that why reflection takes place, and then we will build over that. We will learn more and more about this, that what issues we can have because of reflection. But let's go slow. Let's see and let's learn. So, principle of reflection of radio wave. So, reflection occurs when the wave strikes a smooth surface such as water, a sheet of ice, a very smooth earth, or the boundary between the adjacent atmospheric layer of different densities. So, it means that against our normal principle, because generally when we talk about light, we see that the light reflects from reflective surfaces. Surface is a kind of a must for us. Just I'm talking about our normal understanding. But if when we will discuss it, like we know that, like for example, the light, it is reflected from the mirror. It is reflected from the lakes. For example, in the lakes, you can see the mirror reflection of the earth. But if you remember, if you go in some foggy areas, for example, if you go to mountain areas, you will see that even if you are passing through some mountains and there are some clouds or some high density air, then some of your light kind of reflects back. You see some of the light, it makes things a bit even more brighter, because it becomes brighter because some of your light is coming back to you. So my point was to tell that even sometimes the different density of the areas may also be so much different that some light is reflected back to you. So this is one of the thing which, because it is not in our general understanding, we don't know about it. So I thought to a bit emphasize on it, because when we are talking about the microwave, we have to take care of these things, that some different density atmospheric layers can even work as a reflective surface for us. So let's move. So this is a very normal reflective plane example. This is, for example, you have a link and there is some water body in between. So as we know that if you have a link with a water body in it, and if, for example, the height of both the towers is approximately the same, then your reflection point is absolutely in the middle of the area. So that's why we say that if there is any reason, if you must pass through some water body, then it is better that this comes to a site. For example, you take this point a bit further back. This area, your reflection point don't go in this water body, but it may go in, for example, if this link was a bit longer, if we assume that the link is a bit longer on this side, on this one side, then this reflection point may come somewhere here. Then it may not be hitting it. Also, we have this natural knife edge in between. So this knife edge can at least stop the reflection, not the diffraction, but it can stop the reflection. So this is, I'm giving you just some idea, but right now we are just trying to understand. So this is how we understand the reflection. If you have a link, and if there is any smooth surface, any water body, anything which has a good reflection characteristics, then you can have a lot of reflection. Then how they are seen? So if you work further, if you run the reflections, if you go to the specular reflection, then you can see that the reflections are hitting your link, the receiver side. If you see this center, I try to make a line. So the center is directly hitting this antenna. So that's why reflections are, you can say that they are dangerous, because when you have reflection, then there is a lot of chance that either it should be a constructive reflection or a destructive reflection. If it is constructive, you can have a very high power, and I hope you know that. And if you don't know, then we can learn it right now. that even the constructive reflection is not good, because if it is passing through the overload value, if the rays, when they are combined, if they become too high, then even that high can burn your receiver. And if they are destructed, and then you will have a null at this point. So that's why when we work on these kind of links, we do the specular reflection and we see that what kind of nulls are being created. That we will see in the coming lectures as well. But just now, this was just to explain you that what is reflection, how it is created. We will go further in the detail of it, but I hope right now it will be giving you a very good idea that how reflections are created, and then we will see that how we can avoid and what kind of implication it may have. So I hope that this video should be beneficial for you. See you in my next video. Goodbye.